This is Unit 2 for Database Administration 2, and in this unit we're going to talk about security, connections to the database server, and just generally about user management. So I want to start with user management. There is some supplemental reading that I'm going to give you that covers user administration for MySQL and MariaDB. It's very similar in both platforms, but we just basically want to cover how to create user accounts, how to work with user accounts. And in the lab for these 2 weeks, for this 2-week session, so Unit 2 covers both weeks 2 and 3. We're going to do a series of labs that it's all one project, but we're going to do a series of labs that are going to cover user administration, logging in, and so we're going to start out with creating and editing user permissions and configuring users and so forth. And then the next project, part 2 of the second project is going to cover enabling things like TLS for secure login. And then in part 3, we're going to experiment with some of the plugins for user logins. We're going to learn how to use Unix and PAM, and I'll talk more about those here in a few minutes. I was going to do a lab for using single sign-on with LDAP in MariaDB, but it's pretty challenging to set up LDAP in the Google environment. So you can certainly try it if you want to. I might post some instructions, so there might be an optional part 4, but the first 3 parts, of course, are going to be required. So it's a 3-part project. So let's get started. When we talk about user management, one of the most basic commands is going to be the create user command. So we have to create a user, right? By default, when you installed MySQL or MariaDB, you had a root user account, which probably had no password, meaning that you couldn't just put anything for the password. You had to literally put blank in for the password, right? And in a lot of cases, root also works with the Unix login, which we're going to talk more about those plugins here in a little bit. But to start really using the database engine, we have to create our user accounts. So the create user statement is going to help us create user accounts. One thing I'll caution you is that if you try to run the create user statement and the user already exists, you're going to get an error. But you can add an if exist clause in the create statement. I think the version of MariaDB that I'm using in this course, we're on 10.1, and I'm pretty sure by default it's going to let you do that. But it's always good practice to check if the user exists first. We didn't really talk about procedures in this course or how to use things like conditional logic, but there's an example in the textbook that shows you how to do that. So when you create a user account, it's always going to be in the form of the username at hostname. So, and the hostname is determined by where the server sees you logging in from. So if you have a second machine on your local area network that you're trying to log into your MariaDB machine, it's going to see that hostname from that second machine. So you have to make sure that user account's configured that way. Some people will ask me, Brian, why does it make you create a user account for every iteration of a possible hostname? Well, first, you can use a wildcard. So if you use the %, that means that it doesn't care what the host name is if you have a % in place of host name. So you would do username at and then %, but you have to put single quotes around all of it. So you could do that. You could use the % as a wildcard. And you could also use host name. So one thing you could do is you might configure it so that if somebody's trying to connect from the local host, they don't need a password, so you just leave it blank. But if they're logging in from anywhere else, you want them to use their password, so you'd use the %. And you can even mix and match different login types. So maybe when someone's on the local machine, you allow it to use Unix sockets, which means the Unix user account, so the Linux account that they're logged in as, so they don't have to log in or put their password. But if they're logging in from any other machine, maybe you want them to use their MySQL password, so you can force that. Or you can use PAM authentication when they're on another machine, but the Unix socket when they're on the same machine, right? So you can mix and match this. So it does give you a little bit of flexibility in how people log in. There are some options. First, when you create a user, if you don't use the identified by keyword, and it's not one of the types where we don't need to use a password, then by default they're not going to need a password. Of course, they can't provide one. If you neglect to use identified by password, it will, if you do use a password when you try to log in, it's not going to let you log in. But if you don't use a password, you at least leave it blank, right? If you run the MySQL command -u username and then just leave the -p off completely and just hit enter, you'll be right into the database. It won't even ask you for a password. So identify by password is going to allow you to type in a plain text password, but when it stores it in the database engine, it's going to be hashed. So you probably learned about hashing in other classes. So it's a password hash. It doesn't store it in plain text. But one of the problems you might find is, what if you have to create user accounts, but you don't know what their password is, but you want to leave their password the same as it was on another MySQL server. So in that case, if you use the password, if you add password and then in single quotes the hash from the password from another MySQL or MariaDB server, their password will effectively remain the same. It's not going to get hashed again. So you want to add that password keyword if you already have the hash. You already know what the hash is. That way they don't have to change their password, right? So it'll work. Optionally, when you're creating a user account, if you don't do identified by and then a password, or if you just don't want them to have the password, right? If you want to use a different method, you can use plugins. We're going to learn about plugins in this unit, and I'll talk about those later, but those are going to be used with the via or with clause at the end. So instead of identified by and then a password, you're going to use via or with, and you'll see that in the documentation that I ask you to take a look at in this unit. So you'll see what that looks like. Once you create a user account, you might need to alter it. When you use the alter statement, it supports pretty much the same options that the create user supports. So you can change to a different plugin if you want. So if you don't want them to use the MySQL built-in login, you can switch it to PAM or Unix sockets or what have you. If you just want to make a change to your own account, you can use current user and then parentheses after it, and that would be a surrogate for your username. So you don't have to type out, root at localhost or something like that, right? You don't even have to know what host name you are. You can just do current user, and it'll use the, whatever you're currently logged in as and from whatever host you're logged in as, and edit that account. So that's a good way to change your password. If you're already logged into the server and you want to change your password, that's a good way to do it if you don't want to have to type out your username, although in many cases it's just as easy to type out your username. But again, it has the same options as the create user clause, which we talked about just a few minutes ago. And of course, the time will come where you have to drop users, so it's going to be the drop user command, and this is where you delete a user. So you can certainly do that if you like. You can drop a user when you're done working with the user if they don't need access to the database any longer. You could also just lock their account. So in the reading this week in the Mastering MariaDB, there's some information about how to use locking to lock users for a period of time. So if you just want to keep them from logging in during a certain window or something like that. But by default, a user, by default, when you create a user account, it should automatically grant them permission to log in, but they may not have permission to do anything else. So you have to grant them permissions to do something in the database. By default, you have no permission until you use the grant command. In some cases, if you can use the grant command to both give permissions to users and create that user account. So in some cases, grant will do both for you at the same time. So you don't have to create the user first and then grant them permission. You can just use a grant statement. And again, the reading for Mastering MariaDB has an example of how to do that. Also, the reading from the MariaDB knowledge base has that as well. They give you some examples on how to do that. But it's basically controlled through an option in MariaDB. And if you want to see if that option is set, you can use the show variables command just to see if it's set or not, the SQL mode. So if the SQL mode is set to no auto create user, then when you run the grant command, it will not automatically create it. But if that's not set, then it will automatically create the user when you use the grant command. So it's kind of a shorthand. You can grant all privileges to a user. So, and I'll show you how to do this in the lab. We'll play with this. We actually already did it in the previous lab. I gave you the command to do a grant statement. So you'll see that in the current lab. But that's going to grant privileges, all privileges to a user. So they can do anything they want if you grant all privileges. But you can also grant privileges to other objects. So, like I said, you can do global, which is just everything, right? So it's star.star, right? So it's everything in the database. But you can also define the database name. So if you can say grant privileges to and then the database name. And then after the database name, you could put a table name. So database name.table. And you can list several tables, right? So you can do, you can comma separate them and list a whole bunch of tables that you want that user to have access to. If you do that, if you put the table name in, then it's not going to let them access tables that they don't have access to, right? They won't be able to do any select statements or insert statements. And by the way, you can assign permissions to not only to these at the object level, right? Whether it's a database, a table, a column, which is the next level, or a function or a procedure, right? So you can do database name dot table name dot column name, or dot function name or dot procedure name after the database name. But you can also define what type of privilege. So it could be all privileges, meaning that they can select, insert, update, delete, and execute, right? If it's a stored procedure or a function, they would execute. But you can also define whether a user can do delete or not, right? So you could say they can select and they can insert, but they can't delete or update, right? So they can't mess up the data. They can put new records in, but they can't take records out, right? And they can look at records if they want. Or you can make it so users can insert records, but they can't view them. There are certainly use cases where you would want to do that, right? Now remember, in most cases, a lot of these privileges are at the application layer, and I want to talk about this just very briefly because this relates back to security. Is in many cases, application developers will control their own security, right? So application developers will kind of make their own access control matrix within their applications, and that'll define what they can and can't do in the database. And some people would argue that that's not a very good model, that a better model is where the database is handling those permissions and there's context to the user account in an application that matches the user account in the database engine. So when you log into, say, a web application, those credentials are passed through to the database engine, so the database engine is independently managing what that user is allowed to do. Now, in order for that to work, and this is the important part, and really in order for that to be scalable and to work, we can't use the built-in MySQL accounts, because then you would have to have logins for both your application, but then also you'd have to matching logins in the database engine, which could get which would get very tedious, right? So, in theory, what you could do is you can install an LDAP server, or if you have Active Directory, if you're using Microsoft Windows Active Directory, and you probably have, many of you have probably taken courses about Active Directory, and you know how powerful Active Directory can be as a network operating system. We talk a lot of good things about Linux, but there's no better authentication system out there for networks than Active Directory. It's 99.999% of businesses use it, right? So we might as well support it. But what you could do is you could have MariaDB use the PAM module, which allows you to use the pluggable authentication module in Linux, such that if a user would authenticate to the operating system using LDAP. LDAP works with Active Directory. They would also authenticate to their application, right? So that whatever front-end application it's using the database would also use LDAP. So then the user's context in both the application and the database is both being authenticated and authorized through LDAP, and then you can create the permissions within the database, and you could do both, right? So you could, in theory, you could have both the application layer and the database layer managing permissions to objects. So if all else fails, if the application somehow fails to prevent a user from accessing something they're not supposed to have or supposed to do with the database, at least the database engine on the back end will prevent that from happening. So it's multi-layer security. And when you take security classes, in many cases they'll talk about how having these multiple layers of security is very important. So to see this full matrix of all these permissions that you can set, I didn't want to put them all in here in the slide deck. I put a link there in the slide deck, and again, this is one of the links that you can go look at that I put into Blackboard as well. But if you click on that link, it'll show you that full matrix of all the things that you can do with privileges in the database. It's pretty powerful. You have pretty granular control of the privileges within the database. I would say that probably 80% of the people I know using MySQL or MariaDB are not using all of these features, right? They're just letting the application drive that authentication and the permissions, and then they just have one MySQL account or MariaDB account that's accessing the back-end database. So they're really kind of shifting that to the front end. But it's a good discussion topic, right? Is where should these security functions reside? Should it be in the front end, or should it be on the back end, right? Or should it be in both? And you can make a case for that. If so many people are not using the database engine, maybe there's a reason for that, and maybe sometimes simplicity is better. I don't know. Or maybe, for availability's sake, right, which is the third leg of the CIA, confidentiality, integrity, and availability, and the IT security triad, which you've probably learned about. All right, so that's how we grant privileges. If we can grant privileges, we can also revoke them. It's the opposite of grant, right? So it allows you to remove privileges from users and also from roles. We can also do all this stuff with roles. And if you want to see permissions, if you're not sure what permissions a user account has, you can use the show grants for and then put the username. If you just do show grants, that will show your permissions for the currently logged in user account, but you can look at what permissions are for other accounts with the for and then user at host. And again, you can use a wildcard, so you can just see permissions for that user at all the different host names if you really want to. But that's basically how you check on the permissions. So I touched on roles for just a second earlier. Basically, roles allow you to simplify user management by grouping users together, right? So kind of just a basic system administration concept here that, it's really not scalable. I know I've used that word a couple times in this unit, but it's not really scalable to set permissions for every individual user granularly, right? Typically what we do is we take a large swath of users and we group them together and say, these people all have the same role. They all do the same thing. So they're going to have the same permissions, right? And then we can use that role and just manage the permissions at that role at a global level and apply it to everyone all at the same time. So MariaDB supports that same mechanism. So in MariaDB, you can use roles. So you create roles just like you do in... so you create roles just like you would create a user account. The same concept works, right? So the only difference here is when you create a role, number one, roles don't have passwords, right? I know in Oracle sometimes they can, but MariaDB and MySQL, we just create a role. By default, you probably want to make someone an administrator of that role. So this is the person who has permission to add and remove user accounts from that role, or to set permissions on that role. So this is important because you could delegate authority to manage a role to someone, right? So that particular user may not be a global root of the MariaDB server, but they do have permission when they log in to edit users, within their own role, and also to add new users to their role or remove users from their role, so they can control who has access to their, to what they're allowed to set permissions for. And of course, that cascades through to the permissions that user has. In other words, an admin user that doesn't have permission to certain tables wouldn't be able to provide permission to access those tables to their role, right? So they can only add permissions for what they're allowed to access. So it's kind of a nice mechanism, to cascade those permissions. And again, some of you who have taken Active Directory courses probably see some parallels here to managing Active Directory, right? It's not all that different from something like managing user accounts and roles and groups in Active Directory. It's the same concept, and also the same concept in Linux too, right? Linux has user groups as well, and you can use a very similar concept. But it's really important that MariaDB supports this, again, for scalability, especially if you're using LDAP, you're not going to want to have to manually edit the permissions of all your users that are LDAP users in MariaDB. You're going to want to do that for a role, right? And you can do that with MariaDB. So it's kind of neat when you set up LDAP. Again, we're probably not going to do it in this class because it's pretty challenging, and I don't want to bury you guys with 5 hours of lab work every week. But it is kind of neat how it works, that you don't have to create a user for every single user account in Active Directory when you use LDAP with MariaDB. You can map groups, right? So you can map a role to an LDAP group. So in other words, everyone who's in a certain group in Active Directory will have a certain level of permissions within MariaDB with access control. So it gives you some pretty neat controls, and again, it makes it a lot more scalable, especially with really large organizations. Imagine you've got a database system that's supporting 50,000 users or 100,000 users. Which is not outside the realm of possibility, right? MariaDB is built to run large web applications, so it's entirely possible. Something like you might be asked to administer a very large system. It certainly is a lot easier to set these permissions at the role level and then have them apply to LDAP groups instead of individual users with the traditional MariaDB login mechanism. So again, lots of control here with roles. So the standard grant commands work with roles. So once you have a role, you can use the standard grant commands just like we learned before. And again, in the supplementary reading for this unit, there's 3 or 4 sections that you can read about roles and how to work with roles. So again, lots of neat things that you can do with roles. And again, I just want to stress that I think in the field, in the real world, again, I'm probably not going to have you do this for the class, but I haven't really settled on exactly which labs we're going to do in this unit yet as I'm recording this. But like I said, I may not have you do LDAP only because it's very difficult to set up in a Linux environment. We could stand up a Windows server and do it with that, but it's also kind of expensive to run Windows in Google Cloud. They charge you like $30 a month, so there's that, right? And I'm just not sure if it's worth it, but I really want you to understand the concept that in the real world, I would say that for large scalable systems, you're probably going to be using LDAP authentication with the database. A lot of other database engines support this, right? So Oracle supports LDAP authentication to integrate with a Windows network. Obviously, Microsoft SQL Server is very closely related to Active Directory. It supports the same thing. And incidentally, what a lot of students will talk to me about in this unit when I teach face-to-face classes is, the topic will come up, and even though you're using LDAP for authentication, you still have to create the group and you still have to create the user, in order for them to access the database, in order to manage those user accounts within the database. So you still have user accounts and roles within the database that you manage, independent of Active Directory. And some students will say, well, gosh, if I'm using Microsoft SQL Server, isn't the authentication a little bit more closely linked, right? Where I don't have to manage it in 2 places, so to say. But that's actually not true, right? So Microsoft SQL Server really kind of works the same way. It does pretty much the same thing. You still have to create user accounts and groups within SQL Server. You still have to manage specific database permissions within Microsoft SQL Server. Even though it's in the Microsoft family of products, it doesn't directly use Active Directory for its permissions. It's still managed within that database engine. So I still see DBAs that are in environments where the applications, even in the Microsoft stack, are, even though it's all Active Directory, right? It's all interconnected. They're still using application stack to manage user accounts, internally to their applications, as opposed to, using permissions in the database. So again, it's an interesting topic that you can discuss. And while we're on the security, or on the topic of security, right? User account management goes hand in hand with security. There's this concept of encryption with the database engine. So it's important to note that when we talk about encryption in this unit, we're talking about the data in transit, right? Not the data in rest on the server. So as far as I know, MariaDB doesn't really have any native encryption capabilities for the data within the files system, right? However, if you really want to encrypt that data, you can. There's nothing that stops you from using encrypted file systems. Either at the, something like BitLocker or even in the file system level. Linux has file systems that certainly support encryption, right? So you can certainly do that. But when we talk about encryption with MariaDB, we're usually talking about encrypting the data in transit between the client and the server. So the client being either the MySQL client, or it could also be the an application connecting through an API. Right, so a lot of times we want to encrypt that as well, especially if we're using the cloud, right? Because a lot of that traffic, we don't have a control over where that traffic is traversing in the cloud, so it's important to make sure that it's encrypted. So we want to prevent transfer of passwords in plain text, again, especially if we're using the cloud over the internet. For example, we might have web applications that are running in the cloud that are connecting to MySQL or MariaDB servers. This is common with things like Amazon or Google, where their database engines are running as an instance in the cloud, and we're not really connecting to them through a VPN. We're just connecting to them straight over the cloud. So in those cases, it would be a good idea to ensure that encryption is enabled, so we know that everything's being encrypted, right? Because it's all traversing the public internet. And I'm sure you've learned about encryption in other classes. I don't want to get into exactly how encryption works. Hopefully you've been exposed to that in other courses, but the long and short of it is that TLS is a suite of protocols that supports encryption. It has a handshake mechanism, and you'll see that in the lab when we set it up. We're going to have to use when we set up encryption. We're going to have to create certificates, and that whole process. TLS sets up that encrypted connection, and then all the data is encrypted while it's in transit through a combination of synchronous and asynchronous encryption protocols. So again, it's really important that we turn this on systems that, if any of this traffic is going to be traversing the public internet, we want to make sure this is enabled. It's also not a bad idea to have it enabled, even if it's on a local area network. I would say maybe it's overkill to use encryption if it's all in the same system, right? If your application and the database are all within the same, virtual environment or the same system, maybe it's overkill. I don't know, but that's certainly something you can discuss in class this week. We could talk about, what's the appropriate level of security depending on the applications. When you create user accounts, you can configure it such that user accounts are required to use SSL. So if they try to log into the database without using SSL, it's going to deny them access. Or you can allow them to log in with or without TLS, right? So the database engine will certainly allow connections both with and without TLS. But again, you can enforce that users have to use TLS for when they connect with their client, or if they're connecting through an API. And continuing with our authentication, or switch gears back to authentication, you have these authentication plugins, and I was talking about these earlier. There are 4 common authentication plugins in MariaDB. By default, when you install MariaDB and when you create user accounts in MariaDB without indicating any other authentication plugin, by default it's going to use the MySQL native password. By the way, all the capital letters that you see on the front, when you use these, typically you wouldn't use the capitals on the front, but I don't think it's case sensitive though. But in any event, MySQL native password, and here we see MySQL again, right? Even though it's MariaDB, MariaDB was a fork of MySQL, so there's a lot of vestiges of MySQL and MariaDB. But in any event, the native password is where the passwords are managed inside the database, right? So it's that hash password that's in the mysql.user table. You probably saw that in the previous course, or maybe you saw it in this course when you installed your database engine. I think I show you in the video how to look at your user accounts by using a select statement, so you can see those passwords. And that's the default mechanism for authentication. If you do nothing special with MariaDB, it's going to use the MySQL native password. You could also use the old password mechanism. The only real difference between these two is MySQL old password uses an older hashing mechanism. It's not as secure as the new version. Now you might ask me, when I talk about this in class, students say, why would they even support this old mechanism if the new one is better and it works exactly the same, right? Why would we do that? Well, the answer is backwards compatibility with legacy systems, right? What if I have user accounts that were set up in MySQL 5 point something or 3 point something, 3.23 or something like that, right? And I never really modified some of these applications over the years, but we've gone to MariaDB. Now we're at MariaDB version 10 point whatever. But I don't want to have to go in and recompile applications that are hard coded with passwords, which is a terrible idea, by the way. But it's something we might have to live with in the real world. There might be some reason that we want to keep those old hashes and we can't recalculate, right? The whole point of a hash is that you don't know what the original password was. And even though it's an older mechanism and it's pretty secure, it's still a pain in the neck to go and figure out what those passwords were, right? To brute force those hashes. So in those cases, it might make sense to stick with the older mechanism. So you could certainly do that. So that's going to be the MySQL old password, again, for backwards compatibility. Then you have these other two at the bottom, which are 2 other mechanisms. So Unix socket is, we're going to use that method if we are, if we want users to be able to log into the database while they're logged into the Linux machine. This only works if you're logged into the MariaDB server itself, right? So you have to be on a server that's on the server that's running MariaDB. You're in a MySQL. You're running the MySQL client from that same server. You're logged in as a Unix account, and as long as your Unix account is an authenticated account that has access to MariaDB and it's the same username and the host names match, right? It's gonna do all these checks and it'll let you in with the Unix socket, meaning that it's not going to ask you for a username. So that means when you type MySQL, You don't have to do -u and then a username. You don't have to do -p. You don't put anything. You just type MySQL, hit enter, and you're in the database without doing anything. And again, using your current user account. And you could actually, if you're logged in as root into a machine, in the Linux account, the root Linux account, not the root MySQL account, you can masquerade as a different user, and it'll allow you to do that. But you can only do that if you're a root user, if you have those privileges to do that in Linux. But that's what Unix sockets do, so it certainly simplifies login and user administration if everyone's going to be using the machine itself, but that's not always the case, right? So the other option we have is PAM, or pluggable authentication modules. So basically what PAM is it's an infrastructure that's built into Linux that allows you to extend authentication to other applications within Linux. Socket, the Unix socket is one mechanism, and many applications use that, where it just inherits whatever process thread you're in, right? It's going to use those permissions for that user account. But PAM allows you to use the Linux authentication mechanism out of band without being logged into the Linux machine itself. And where this is valuable is, what if I'm on a Windows machine trying to log into my server, into my MariaDB server? I certainly can't use Unix sockets in that case, right? That's never going to work. So this mechanism does a challenge response. In other words, it asks you to use a username and password to try to log in, and it's going to authenticate you. It's going to pass those credentials through and authenticate you through Linux on that local machine. So that means I can manage my user accounts within that Linux server, even if they're logging into MariaDB from applications, through APIs, through things where the Linux user socket is not available. It won't work. And to take that one step further, again, I talked about this before. If you're using LDAP is going to work with PAM. So, in other words, when you configure a Linux machine to do authentication with LDAP, and it's kind of an extension of PAM itself, right? So what you do in your Linux machine is you configure Linux to use LDAP for authentication. So the PAM module is actually going to go out to LDAP instead of using local accounts. And then when you set up the PAM module in MariaDB, because it's asking the PAM in Linux to do the authentication, which is then using LDAP instead of local accounts, it kind of cascades all the way through. And then there's some capability in MariaDB to map roles to LDAP groups as well, which actually would work in Linux groups. That would also work, but usually you don't need that kind of scale when you're working with Linux users, so it's, I think, more common to see it with LDAP. But it works, right? You could do that, so you can use LDAP. I don't know, there are other authentication mechanisms out in the world, such as SAML and OpenAuth 2.0, and I don't know specifically how you would do that with MariaDB, so that would be an interesting project, right? If we research how to authenticate users to MariaDB using something like SAML, and I think it could be done because you can actually use LDAP to authenticate using SAML and OpenAuth, and I've heard tell that you could actually even set up LDAP authentication through MariaDB to do one-time tokens, right? So you can actually configure it so that when a user goes to log into MariaDB, it forces you to use a token, right? It could be an RSA key, it could be something you text to the user, where they have to put a one-time token in, and then it allows them to authenticate to MariaDB. So you can make it very secure, right? You could go pretty deep with this security, but again, we have to kind of weigh what's an appropriate level of security, right, when we look at this stuff. So finally, I'm going to talk about connections a little bit here, not too much, but by default, each connection to the server is one thread. In other words, every user account that's doing something with the server is a single thread. Now, the reality is that most applications, when they're using the database engine, they're going to open a thread to the database server, they're going to open a connection, do some queries, and then close the connection when they're done. And that's going to be a thread. And they're very ephemeral, right? They're not going to be open for a long time, unless they're running, long, complicated queries. They're not going to be open all the time, right? So even though you may have thousands and thousands of users, you might have 50,000 users on your, using your MariaDB instance, but they're not all going to be connected at exactly the same time running queries, right? Think about when you're looking at a web page in a web application, you're consuming the information on that page most of the time, and then you're clicking the button to submit a form or to get information from the web application just periodically. The overall time that you're actually interacting with the database is very low, at least if it's a well-designed application and everything's tuned properly. We'll talk about that later on in the course. But again, it'll keep those thread counts pretty low for those connections. Now, that said, and by the way, that whole concept is online transaction processing. You'll see that term. And that said, MariaDB, starting in, I think in version 10.1, it does thread pooling. So what that means is that more than one connection can use a single thread. So you have one thread that pools many connections. So if you think about it, MariaDB, when it's running on a server, based on the resources that are available within that particular machine that it's running on, really dictates how many threads you could possibly have open, right? So what MariaDB will try to do, what the database server will try to do is configure the number of threads that's appropriate. That'll give it the best resource utilization, and then it'll allow many different connections to share that same thread. And if that one thread runs out of connections, it'll start rolling over to additional threads, right? So I could have, instead of having 5,000 threads, each with one connection, I could have 100 threads, each with 500 connections, right? And it's a little bit more efficient to do it that way. One thing about threads is that every time you stand up a thread and tear down a thread, it's going to take resources to do that, right? So if I can pull these connections, it's a little bit better. I would say that most modern database engines have this capability, right? So if you look at most modern database engines, they're going to have this whole threading concept. Oracle for sure has it. Microsoft SQL Server has it, although it's usually turned off by default, but you could turn it on. There's a couple different options for threading in many different database engines. And of course, MySQL also does this. So it can be very efficient. It's controlled in the MySQL config file. So if you want to enable this threading mechanism and configure how it works, so in this supplemental reading for this unit, I'm going to provide a link that explains all the different options for thread pooling, and we'll kind of explain what it does for you. I don't think we're going to do a part of our project. I don't think we're going to necessarily play with threading, but we certainly could. But in any event, that's where you set the options, is in the config file, like many things in MariaDB. And then there's also some other variables in there which which you'll see when you look at that documentation. So that's it for this week. Again, this is a 2-week unit. We're going to have a bunch of parts to our project, right? So it's not going to be just one project that you do. It's going to be a series of parts for that one larger project, and that's reflected, of course, in the percentage of the grade that this project is worth. I think this week's project is worth 15%. Last week's was worth, I think, maybe 5%. So, this one has 3 times the weight as last week's assignment, but it's going to span 2 weeks, so I'm going to give you plenty of time to get it done. And we're going to do some topics on user management and security. And if you have any questions, let me know. Thank you.